All right, let's start Unit 4, Properties of Exponential Functions. So in this unit, we will discuss about exponential functions as well as logarithmic function. So our first discussion will be just to understand the laws of exponential functions. So I'll start with the laws. So I'll say here for a and b positive, that is a different from 1, b different from 1, and x and y are real numbers. We have the following laws of exponent. The first one is, if you have the same base, a to the x times a to the y, you can a to the this one a y, so you can represent by a single base, and you have to add exponent. By the way, this one as a definition, for example, this is the lower one is known as the base of the exponent, and this is known as exponent. So when you represent any exponential function, for example 2 raised to the fifth, this is known as exponent. This is known as the base of the exponent. So the first rule is, if the exponent had the same base but different exponent, you can represent as a single base and add the exponent. That is the first one. The second one, if you have the same base but division, so you can use the same base x minus y. This is important laws. The third one is a product, for example, ax another power, so x times y. So to clarify this one with example, for example 2 to the third, another 4 here, 3 times 4, and 2 to the 12. So the base is 2, the exponent is 12. The other important rule is, if you have different base but multiplication and represent by an exponent x, so this exponent goes to each base. Example, for example 2 times 3, and this one is to the base is 5, so 2 to the fifth times 3 to the fifth. Number 5, let's say division, a divided by b, we have the same exponent, so you can attach the exponent to each base. For example, let's say 2 over 5 to 6, so this can be 2 to the 6 over 5 to the 6. The other one is, I can say a to the 0 is 1, where a is different from 0. So this one is also we use for different purposes, so please make sure a base which is different from 0 to the 0 is 1. For example, let's say 10 to the 0 is just 1, or any number to the 0. And switching positive to negative exponent, so a to the positive y can be written as a to the negative y. Example, for example 2 to the 7th can be written as 1 over 2 to negative 7. Or this rule is a to negative y 1 over a to the positive. That is example here. For example 2 minus 4 can be written as 1 over 2 raised to 4. So these are the basic exponent rules. So please make sure to be familiar with this one in order to simplify any exponential expressions. So I'll come to the next video by using these rules, and I'll do some examples of exponential expressions.